Morning students, Sairam, this is Megha Miss here, and today we will continue with our lesson number 8, that is metallurgy. We have started the chapter. Now this is our session 3. Okay students, now till now you have studied about the chemical properties of metals and non-metals. Yes, we have seen the different types of reactions. Now we will proceed with the lesson. Okay, the next part which we are going to study, that is the ionic compounds. Now you all have studied about ionic compounds, right? Now what are these? The compounds formed from two units, namely cation and anion, are called as ionic compounds. Yes, in the ionic compound you have a cation and an anion. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. So there is a charge, positive and negative charge, as they are opposites. Yes, they will attract each other. With which? With the electrostatic force. You know that this force of attraction between cation and anion is called as the ionic bond. What you will call it, students, as ionic bond. So in ionic compounds you will have the ionic bonds. Okay, the number of cations and anions in a compound and the magnitude of the electric charge on them is such that the positive and the negative charges balance each other. Okay students, so as a result, an ionic compound is electrically neutral. Okay students, so we'll call the ionic compound, it is electrically neutral. Okay students, I hope whatever we have seen about ionic compounds you understood now. Okay, we'll proceed. Ionic compounds are crystalline in nature. The surfaces of all the particles of a crystalline substance have a definite shape. Okay, now all the crystalline substances will have a definite shape and are smooth and shiny. Okay, the regular arrangement of the ions in the solid ionic compounds is responsible for their crystalline nature. Okay students, so the regular arrangement of the ions in the solid ionic compounds is responsible for their crystalline structure. So how the ions are arranged in a regular pattern, that is responsible for its crystalline nature. Okay, the arrangement of the ions is different in different ionic compounds, and therefore the shapes of their crystals are different. So all the ionic crystals have got the different shapes. Okay, why? Because the arrangement of the ions is different in different ionic compounds. Okay students, now the main factor that determines the general arrangement of ions in a crystal is the attractive force between oppositely charged ions and the repulsive force between similarly charged ions. Yes, if there is a force of attraction between the opposite charges, you have similar charges also, right? So there will be a repulsive force also. Okay, because of this, the general crystalline structure has negative ions arranged around a positive ion and the positive ions arranged around a negative ion, so that this crystal structure will be helpful for this study. Okay, so negative ion, it is arranged around with the positive ions, and the positive ion around you will have all the negative ions. Then only there will be the force of attraction and it will lead to a crystalline structure. Okay students, now the two important factors responsible for a certain crystal structures are as follows. Now what are the two important factors, students? First, you will remember size of the positively and negatively charged ions. Okay, how much big or small the ion is. Okay, second, magnitude of the electric charge on the ions, means whether it is giving away 2 electrons or 1 electron. So the value, magnitude means value of the electric charge. You have na mg plus 2, mg plus, yes, like this. So 2 electrons can be given, 1 electron can be given, and that much charge is there on that ion, right? So it depends upon the magnitude of the electric charge on the ions. Okay, the electrostatic attraction in the neighbouring ions with opposite charges is very strong. That is why the melting points of ionic compounds are high. All the ionic compounds, you will see that their melting points are very high. Also the ionic compounds are hard and brittle. Okay, do remember this. So properties of ionic compounds we are going to study. Before that, we are going to do a small experiment. Now what is that, student? Apparatus. You will be requiring metal spatula, burner, carbon electrodes, beaker, cell, lamp, press key, electric wires, etc. Chemicals, you will require samples of sodium chloride and barium chloride, water. Procedure. What we have to do, students? Observe the above samples. Place sample of one of the above salts on the spatula and heat it on the flame of a burner. We'll heat it. Okay, we'll take some, spatula is like a spoon. Okay, so in that I'll take some sodium chloride. For example, first chemical what I have taken, and I will heat it on the flame. Okay, repeat the procedure using the other salt. As shown in the figure, we'll see in the next slide. Assemble an electrolytic cell. I'll have an electrolytic cell. Assemble an electrolytic cell by using a beaker. I'll require connecting the carbon electrodes to the positive and negative terminal of the cell. Dip the electrodes in a solution of any one of these salts. Do you see the lamp glowing? Check with all the other salts as well. So see here, you can see here the picture what I am talking about. To heat the salt sample, for example, if I have taken sodium chloride, I will take it in the spatula, you can see in the diagram, and I am heating it. Okay. Same way to check conductivity of the salt solution. What I will do, I will take the salt for sodium chloride only. First one I will take, I will put it in the beaker. You can see salt solution is written. Graphite rods I am using as my electrodes. Okay. One will be positive electrode, one will be the negative electrode. It will be connected to the electric cell. You can see here the electric cell I will require. These are my two electrodes. Okay, I am going to have the lamp to see when I am joining the circuit whether the lamp glows. Okay, and I have a press key. Okay, and a beaker, graphite rods I told you now, and I have to check whether the bulb glows. Okay, so we will see that some of the ionic compounds, they have the capability to conduct the electricity. Okay, so when you take sodium chloride, yes, electricity can pass through it. Okay, so we'll see some general properties of ionic compounds. The attractive force between the positively and negatively charged ions is strong. Okay, so remember, the attractive force which is there between this positive and negatively charged ions is very stronger. Therefore, the ionic compounds exist in solid state and are hard. We cannot easily break them. Okay, so they are very hard. The ionic compounds are brittle and can be broken into pieces by applying pressure. Okay, but when you apply a lot of pressure, yes, they can be broken because they are brittle. Okay, but in solid state they are hard. Okay, but when you apply a lot of pressure, yes, they can break. Okay, and they are brittle in state. Is it clear, students? I hope till here it is understood. Okay, now third property, the intermolecular force of attraction is high in ionic compounds and large energy is required to overcome it. So if I want to break the intermolecular force, I require a lot of energy. Okay, now only I told you I have to apply a lot of pressure. Therefore, the melting and boiling points of ionic compounds are high. Okay, you can see this table is given in your text. Please go through that table. Okay, you can see different compounds are given. H2O, ionic, non-ionic. Water is non-ionic. 0 is melting point, boiling point is 100. You know this. ZnCl2, it is ionic compound. MgCl2 is an ionic compound. NaCl is an ionic compound. NaBr is an ionic. So you have to remember these examples also. Okay, KCl is an ionic compound and MgO is an ionic compound. And values, for example, NaCl is very common. So you have to remember what is its melting point, boiling point and all. Okay, so please go through the table properly. And at least which are there, like NaCl, H2O, you know, KCl you remember. Okay, like this, which are again and again the compounds which we are using. Remember the melting and boiling points. Okay, students, I hope till here it's clear. We'll proceed. The fourth property. Okay, ionic compounds are water soluble. This is because the water molecules orient in a particular manner around the ions separated by dissociation process. Okay, so they are water soluble. For example, we are taking NaCl. So when I am dissolving NaCl in water, Na plus and Cl minus ions will be formed and Na plus ions will be covered now. Around will be the water molecules. Okay. As a result of this, a new force of attraction is established between the ion and the surrounding water molecules, replacing the original intermolecular attraction. And aqueous solutions of ionic compounds are formed. Yes, aqueous means a salt solution is formed. Okay. Ionic compounds are, however, insoluble in solvents like kerosene and petrol, but we cannot dissolve them. Ionic compounds cannot be dissolved in kerosene and petrol. This is because, unlike water, a new attractive force cannot be established in this solvents. A new force of attraction does not form. Okay, but if you dissolve it in water, a new force of attraction is formed with the water molecules. Okay, I hope till here the 4 properties you have understood. Okay, we'll move to the next property. The ionic compounds cannot conduct electricity when in solid state. Okay, see, in that also NaCl solution I told it can conduct because it was dissolved in water. Okay, in this state the ions cannot leave their place. However, in the fused molten state they can conduct electricity, as in this state the ions are mobile. The ions should move here and there. Okay, mobile means move here. Okay, the aqueous solutions of ionic compounds conduct electricity as they contain the dissociated ions. On passing current through the solution, the ions move to the oppositely charged electrodes. Okay, due to the electrical conductivity in fused and dissolved state, the ionic compounds are called electrolytes. What you will call the ionic compounds as electrolytes. Okay, why? Because due to the electrical conductivity in fused and dissolved state, means in aqueous state you can say, in a fused state you can say, the ionic compounds we call them as the electrolytes. Okay, you have studied, students, electrolysis in your 9th standard also. Please go through that again in 9th standard textbook. Please open it, see it. Okay, in the lesson number 5 we have studied it. Please go through it, electrolysis process. You will understand it more better. Okay students, ionic compounds we have studied last year also. Please go through that. You will understand the electrolysis process and all very nicely. Okay, open the chapters, starting chapters of chemistry in 9th standard textbook and go through them. Okay, so we'll proceed. Metallurgy. Now we are starting. Till here we have studied about the ionic compounds. You already know what were the ionic compounds. Simple example you studied many times was the NaCl. MgCl2 also you saw last year. So all these are the ionic compounds and we saw their electrical conductivity. Okay, now we are starting with the lesson name itself, that is the metallurgy. Okay, now what is this metallurgy, students? The science and technology regarding the extraction of metals from ores and their purification for the use is called the metallurgy. Okay, so the science and technology which is regarding extraction of metals. I'll extract it from the ore and then I will purify it for the use. That is called as metallurgy. Occurrence of metals. Now where do we find these metals? Most of the metals being reactive do not occur in nature in a free state, but are found in combined state as their salts such as oxides, carbonates, sulfides and nitrates. Okay, so in combined states you get them. However, the most unreactive metals that are not affected by air, water and other natural factors like silver, gold, platinum, these are the 3 one, they occur in the free state in nature. Okay, these 3 metals. The compounds of metals that occur in nature along with the impurities are called the minerals. Now what are minerals, students? The compounds of metals. Okay, metal compounds which are present in nature with lot of impurities, we will call them as the minerals. Okay, so the minerals from which the metal can be separated economically are called ores. Economically means to increase the use of the mineral for the industrialization process for earning money. Okay, so the minerals from which the metals, okay, we need the metal, right? We need the metal for different types of processes in our whatever are going around us. Okay, so the minerals from which metal can be extracted for the economic growth, we call them as ores. Ores contain many types of impurities such as soil, sand, rocky substances along with the metal compounds. These impurities we call them as gangue. Metals can be extracted from their ores by a means of various methods of separation. So we are going to study the various methods of separation, how you can separate these gangue particles from your metal compounds. Okay. The process of extraction of this metal in the pure state from the ores is called the part of metallurgy. Okay students, so what is metallurgy? The process of extraction of metal in the pure state from the ores is called the part of metallurgy. Okay students, I hope you understood till here. Okay, so ores are taken out from the mines and the gangue is usually separated from the ore at the site itself by the various method. So the mining site, wherever mining is done, from that ores are removed, and that ores, whatever the impurities are there in that ores, are removed at that site only, at that place only. Okay, then the ores are carried out to the different place where metals are produced. Okay, so in industries they send this ore now. Okay, the metals are extracted in the pure form, then different types of different processes are done on that ores, and washing that ore properly to remove the remaining gangue particles, and then some reactions are done upon it, so that from that you can get the pure form of the metal which you need. Then the metals are further purified by the different methods of purification, because you need at least 99% pure metal you should get. So many steps are followed for this purification. Okay, this entire process is called as metallurgy. So whatever all this process is done to get a pure metal from the ore, we called it as the metallurgy. I think you have understood the concept. Okay, so students, we came to the end today. So today we studied about ionic compounds. You studied, it was just a revision part students, because ionic compounds you have already studied. As I told you, please open 9th standard textbook and go through again. Okay, then properties of the ionic compounds, we studied 5 main properties. You have to remember, learn by heart them. Okay, and then we saw the concept of metallurgy. Okay, what are different methods which we can use in this metallurgy for the purification process of the ore, and from that ore getting a pure metal, we'll be studying in the next presentation. Okay students, so I'll stop today for here. Okay, take care, sign off.